Okay, what we really want to be able to do is find factors of our polynomials. So here's a factorized polynomial. P of x, some polynomial, is a factor of x minus 2 times something else, some other polynomial. I don't care what it is. Even if I don't know what this is, I can still work out what P of 2 is. P of 2 just means I replace all the x's by 2's, and that's going to make this bracket here equal 0. And this other polynomial will work out to some other answer, but 0 times anything is 0. So when I put 2 in, if x minus 2 is a factor, then I'm going to get 0. So the idea is that whenever I've got a polynomial, if I put 2 in, it could be any number, but let's say 2, if the answer is 0, that corresponds to x minus 2 being a factor. Notice that factors are always complete brackets including an x. Okay, well, how does this number 2 relate to the factor? Well, the answer is it's the value of x that makes the factor equal to 0. So if I had a polynomial and p of minus 1 was equal to 0, then that would correspond to a factor that equals 0 when x is minus 1. So an example of that would be x plus 1 would be a factor. Or I can work it the other way around. If x minus 3 was a factor, then what I call the magic x that would make the polynomial equal 0. What value of x makes the bracket equal 0? Answer 3. So P of 3 would equal 0. Okay? So in general, for any factor at all, okay, that thing is a factor if the value of x that makes the factor equal 0 when I put it into the polynomial gives me an answer of 0. Now this is called the factor theorem, and I'll prove it in another video, but we want to just charge ahead and start using it. Okay, so now I've got a polynomial. I'm told to put 2 values into it, so let's do that and see what happens. So for P of 2, okay, normal routine, all of the x's are going to become brackets with 2's in. And I know that 2 cubed is 8. I know that 2 squared is 4. When I multiply by 3, I'm going to get 12. 2 2's are 4, so take away 4 and take away this other 4. And the answer here is 12. Okay, so we haven't found a factor, because we need to get 0 in order for it to be a factor. So let's try the other one. So I'm going to do P of minus 1. Same routine with a minus 1 in each bracket. Minus 1 cubed is minus 1. Minus 1 squared, though, is plus 1, so that's just going to be plus 3. Minus 2 times minus 1 is plus 2. Take away 4. And if you tot all of this up, I do get 0. So that's exciting, okay? That means that when I put minus 1 in, I get 0. So the factor corresponding to minus 1 is x plus 1 is a factor, because this is the bracket that equals 0 when x is minus 1. Okay, and here's kind of the same idea, but this time we're starting with factors, and we've got to test whether they are or not. So to test x minus 1, I need to decide what the magic x is. By the magic x, I mean the value that I'm going to need to put in, which is the value of x that makes the bracket equal 0. So for x minus 1, I need x equals plus 1, because that will make this equal 0. So I do P of 1. I substitute 1 in. And so I put 1's in for all the x's, which gives me 1 plus 2 minus 1 plus 6, which is 8. And my conclusion from that is I didn't get 0, so this is not a factor. So that was a bit dull. Okay, but sometimes that happens. Okay, I'm given another one to look at, x plus 3. So for x plus 3, the first thing I have to do is decide the magic x. Okay, well, the magic x is the one that makes the bracket equal 0. So for x plus 3 to equal 0, x will have to equal negative 3. So I'm going to look at P operating on minus 3. So I'm going to sub it in. Here we go, and now we've got to work each of these ones out. Negative number to an odd power is negative, so this is minus 27. This is plus 9 times 2 is plus 18. Minus minus 3 is just plus 3, and then plus 6. And if you work this out, you get 0. So great, we've done something. We have discovered, therefore, x plus 3 is a factor. So you always state the factor you found. It's always a complete bracket, including an x. Good.